All right, thank you guys so much. All right. Okay, we are doing sequences and series, and today we are actually just revising something we did last year. I think Miss Janssen taught you guys number patterns last year. Do you remember that? All right, so she taught you all about linear patterns, which now in grade 12 just gets a new name. All right, we can write linear patterns, but we now refer to them as arithmetic progressions or sequences. All right, same content, just a different name. Can anyone remember what the definition of a linear pattern is? What makes a number pattern a linear pattern? Anyone remember? Robert? The first constant difference. Yes. All right. So you are adding the same number every time when you go from one term to the next. So let me just get a nice example here. I don't want to make something up now. And then it doesn't work. For example, if we are doing like 4, 7, 10, for example, then we can see that from term 1 to term 2, we are adding, from 4 to 7, we're adding 3, all right? And then from 7 to 10, from term 2 to term 3, we are adding the same number. All right, so this, remember we usually write it like this, we show that we added 3, and we are then adding 3 there as well. All right, so we have a constant first difference, and that is what makes it a linear pattern or an arithmetic progression. And guys, we are actually going to refer to these as APs. All right, so you can just make a little note there. An AP is a linear pattern, basically. All right, so we have a constant. First difference. And hopefully you guys remember that we use a D for that. And in this case, the value of that is 3. Okay, now they can ask you various questions about this number pattern. All right, they can ask you to find the general formula or the general term of this number pattern. Now, when they're asking us the general term or the general formula, they are wanting a formula that will give us the value of any term in this number pattern. All right, so instead of having to add 3, say 100 times, they want us to write a formula that will allow us to find the 100th term. All right, just by using that formula instead of adding 3 a bunch of times. Can anyone remember that formula that you learned last year? Yes, yes. All right, so this was the formula, guys. Write this down, please. Cn, the nth term, the general term, is equal to A plus n minus 1 times d. Right, so we can just write little notes on the side just to remind ourselves what each of those variables actually represent. We've already spoken about d. D is the constant difference. Okay, but if we're going from the beginning of this formula, from the front there, Cn is the general term or the nth term. Anyone remember what A is? The first term, yes. So A is the first term in that number pattern. And we remember that first term we will write as T1. Right, second term is T2, third term T2. Okay, D, I'll add that into along because we've already spoken about that. That is the first difference. Then N can mean different things based on the question, right? So N can either mean the term number, so if they're asking you for term 100, the term number is 100, so N will be 100, right? Or it can mean the number of terms. Right, so depending on the question, basically anything that has to do with number of terms, term number, that will be the N value. Okay, so let's now actually find the formula for this number pattern. So we have, I'm just going to rewrite it here. Tn is equal to, now what is A? What is the first term of this number pattern? Can we all agree that it is 4, right? So our A value is 4 plus, now that's if we're finding the general term, the nth term, we don't have a value for n. Does that make sense? If they're just asking for the general term or the general formula, did they tell us which term we're looking for specifically? No, right? They didn't tell us that we have 100 terms or we're looking for term 100. They're looking for the general term. So we are actually going to leave n as it is. Okay, so we're going to leave that as n minus 1. And then what was the constant difference in this case? 3. Please put that 3 in brackets so that you remember that you must now actually multiply it into that bracket. Okay, this is actually a strange way of writing it. We usually, when we have a number that we want to multiply into a bracket, we would put the number in front of the bracket like that. All right, that's how we usually write. Okay, you can write it like that if you want. All right, but basically what I'm trying to say is that we now need to multiply this 3 by the n and by the negative 1. Okay, so that's going to be our next step. 4 plus n times 3 is 3n, and negative 1 times 3 is negative 3. Now lastly, we just need to tidy that up because 4 minus 3 is just 1. Okay, you can write 3n plus 1, you can write 1 plus 3n, it doesn't matter. And that is the final answer. Okay, that is the general term, the general formula. We can now use this formula to find the value of any specific term in this number pattern. All right, so that will be the second question, where they now say find the value of term 100. Right, they can also put the value of any term. I'm just using 100. We have been speaking about that for higher up. So guys, we have a formula for term n. If they're asking me for term 100, what is my n value now? 100. All right, they're giving us the n value by asking us for term 100. The term number they've given us. All right, the n value is the term number, term 100. Okay, so now we're just going to use our formula from up here. Term 100 is going to be 3 times n, but now n is 100. So 3 times 100 plus 1. Right, so we're using our formula that we calculated in the first step, and we're just having an n place. 3 times 100 is 300, right? Plus 1 is 301. That is the value of the 100th term in this number pattern. Okay, we all fine up until this point. Right, we did this last year. Okay. Another option, say you didn't do this in the first thing. Say they just gave you the number pattern 417 and asked for term 100. Right? You could have done this differently. You could have found Tn and then subbed in n equals 100. But you can also just use the basic formula a plus n minus 1d and substitute all your values in from there. All right, this is if you didn't do this thing. If you didn't have your 3n plus 1. Even if you did have your 3n plus 1, you can still use this method. Okay, I'm just showing you another method. If they're now asking for term 100, can't I write it like this? With a backward version. Term n is a plus n minus 1 times d. Right? So the number here in your subscript there, in the formula you use that number minus 1. You see that? N and n minus 1. This number here is 1 less than the number in the subscript. So if they're asking me for term 100, that will be the same as a plus 100 minus 1 times d. Right? Does that make sense? We are going to use this quite a lot going forward, which is why I'm showing you guys. 99 is the same as 100 minus 1, which is what the formula is telling me I have to do. Right? So term 100 I can write as a plus 99d. Term 7 I can write as a plus what's 7 minus 1? 60. Term 15 I can write as a plus 14d. All right, we're going to use that now. So guys, what is my a value? Remember, if we didn't work this out, we're using the actual formula, which is on the formula sheet, the one that we learned from last year. A is 4 plus 99 times, what was my difference again? Here we go, 3. Right, so you can just substitute those values into the actual general formula, not the specific one that we calculated for this number pattern. Okay, and if you work that out, you will also get an answer of 301. Okay, it's up to you which method you want to use. Both are fine. Okay, all right. Now, if they are giving you a question like this, okay, this was kind of the first. Sorry, I'm just thinking I want to do another practice here. All right, number 3 of the same number pattern. Which in the sequence is equal to 34. And now this is a number that you can actually kind of do by inspection. It's not that difficult, but just to go over the method that we use for this kind of question. Now they're asking which term. So they're asking for the term number. Right? And which variable is the term number in our formula? You wrote it down. The term number is n. Right? So they are actually asking us for the n value. That will give us a term which is equal to 34. So now they've given us a specific term. All right, so what we're going to do is we're going to make this 34 actually equal to term n. We don't know which term that is. It might be term 10, it might be term 11, it might be term 12, we don't know. So we're going to make that equal to term n and then solve for n in the formula. All right, so the formula that we have for this specific number pattern is Tn equals 3n plus 1. Now I'm going to make 34 equal to Tn. Right, whenever they've given you a specific term, you need to make that term equal to t. Okay, and then we can figure out which term it is. Now guys, this is just a straightforward equation. Okay, to get rid of this plus 1, I'm going to minus 1. So 34 minus 1 is 33. So that is equal to 3n. And then what must I do to get rid of this 3 in front of the n? Divide by 3, right? 33 divided by 3 is 11. So n is equal to 11. And what does that mean? This is kind of an optional statement. Please write it for this example, so that you know what that answer actually means. You're saying that n is 11. That means that the 11th term is 34. Right? That's what they were actually asking. Which term in the sequence is equal to 34? The 11th term. Okay, but you can leave your answer like this. You'll get 2 marks up until this point, but just write that down. I think you did questions like all 3 of these last year, right? Okay, now a new type of example. Let's make a new heading. Let's write application examples. We'll see if we can get through 2 of them. Yeah, the French something. Okay, guys, we have been given the value of the 3rd term and the value of the 7th term. And we're asking for the values of A and D. Now, in this case, because the 2 terms that they've given us are quite close together, right? Term 3 and term 7. You could do this one by inspection very easily. I want us to come up with a method that we can use when the values of or the terms are very far apart. Because maybe they gave us term 3 and then term 9. Okay, then we can't just do like jumps. Oh, how many times did I jump? What is the difference? Okay, so what I want us to remember is that if they are telling us that it's an arithmetic sequence, a linear pattern, we are going to work with this formula. They have given us term 3. They're saying that term 3 is -4. Okay, I'm just writing that in a bit of a more mathematical way. All right, term 3 is -4. And they told us that term 7 is -20. Now what I want us to do is let's rewrite term 3 using this formula. Right, so if we have term 3, what is the n value here? If it's term 3, n is 3. Okay, I'm just going to add that. So for term 3, n is equal to 3. So if I want to now use this formula, a plus, what is my n value? 3 minus 1d. Does it make sense that I can rewrite term 3 as a plus 2d? A plus a minus 1d, a plus 3 minus 1d. That's where that 2 is coming from. That's what I said on the previous page. Term 100 is a plus 99d, right? Always one less than the term number. So if we have term 3, we can rewrite that as a plus 2d. Okay, I'm just going to write here, going from the 2, that is coming from 3 minus 1d, like that. Right? A plus n minus 1, so 3 minus 1d. Okay, and what is the value of that term? Negative 4. I'm going to go backwards. Right, we can do the same thing for term 7. Term 7 is going to be a plus 6d, right? 7 minus 1d. Because if they've given us term 7, the n value is 7. So if I'm using this formula, a plus n minus 1d, it's going to be a plus 7 minus 1d. And we all know that 7 minus 1 is 6. So a plus 6d is equal to negative 20. I'll just put a note here that 60 is coming from 7 minus 1. Now guys, I hope that you can now look at what we have here and recognize that we have two equations with two variables. Right, so we see that? A plus 2d, a is a variable, b is a variable. Then we have another equation. A plus 60, a is a variable, and b again is a variable. How about if we have two equations with two variables, we're going to have to solve them simultaneously. Okay. All right, this just on the side. Two equations with two variables. We can solve they solve simultaneously. And guys, this is something that we're going to use a lot in this chapter. Okay, often we are going to have two equations with two variables. The equations might be slightly different from these ones. We're not always going to work with this one formula, but that's something that you need to be able to recognize. Okay, so I want you to take yourself, if you see two equations with two variables, you must solve them simultaneously. So guys, remember when we are solving two equations simultaneously, we need to isolate one variable in one of the equations. So it would actually be, we could choose either one of these equations. I'm trying to just go with the first one because it's written first, but it doesn't matter. We are now going to make A the subject in this equation. Right, it's a very easy thing to do. We're just going to remove the 2D over. Yes, Jasper? Yes, you can do that. Yeah, not everyone does that, but you can. Yeah, so the A value will always have. Okay, so here I've moved from 2D over, it's become minus 2D, and now you must take this expression for A, remember, and replace the A in the other equation with that expression for A. Right, so the second equation was A plus 60. Now instead of A, I'm going to write this new expression for A. So I'm going to say negative 4 minus 2D plus 60 is equal to negative 20. All right, so let's see here. This expression for A, we are now substituting place of A in that equation. Because now what's happened? Now we only have D in that equation. All right, so now we can solve for D. Remember, that's the purpose of simultaneous equations. We want to solve for the two variables. Okay, so we have a negative 4. Here we have negative 2D plus 60. What's that? Negative 2D plus 60? 4D, right? Now, obviously, I'm going to move this negative 4 over to the other side. We already have a negative 20 there. When I move the negative 4, it's going to become plus 4. So what is negative 20 plus 4? Negative 16. Good. And now to get the D value, to get rid of that 4 in front of the D, we need to divide by 4. Negative 16 divided by 4 is negative 4. Right, there we have the value of D. So the constant difference in this number pattern is negative 4. Meaning we're subtracting 4 every time, right? Remember, if the constant difference is a negative number, you are minusing that number. All right, and now we need to still find A because the question was asking for the values of A and B. We have D, so we need to find A. This is like a formula for A. All right, so once we have our D value, we can now sub that back into that first equation in the place of D and actually calculate our A value. All right, so therefore A is going to be negative 4 minus 2 times negative 4 because that is the B value now. Right, what is negative 2 times negative 4? Negative times negative is actually a positive, right? And 2 times 4 is 8. So this is actually negative 4 plus 8, which is 4. Okay, so guys, that is what you guys do whenever they are giving you two terms of a number pattern. You're going to use the, in this case, A plus B minus 1B formula to rewrite those two terms in terms of A and B and then solve simultaneously. So guys, they don't always ask you just for the values of A and B. They might ask you for the values of the first 3 terms, for example. Then you must remember, okay, A is my first term, all right? So 4 will be your first term. Then if you have your first term, how do you get to your second term? You can, yes, but let's just look at what we have here. You could do that. But if you have A and you have your first difference, your constant difference, right? If my first term is 4, how am I going to get to the next term? By minusing 4. Right? Shall I add that? You guys are looking at me like I'm speaking a foreign language. Okay, let's just add that. Find the values of the first 3 terms, or however many, they can ask you for any number of terms. You remember that term 1 is A, right? So our A value, which is 4, is term 1. We have our constant difference. It's negative 4, meaning that to get from one term to the next, we have to subtract 4. Now, what is our first term? 4 minus 4. 4 minus 4 is 0. So that is the next term. Then we'll do the same thing to get to the third term. What's 0 minus 4? Negative 4, yes. And those are the first 3 terms. Okay, we're fine. Right, let's see how we're doing for time. 20 minutes left. Okay, I want you guys to practice some of these. There is still another example with the water tomorrow. Oh, where did you guys get? Oh, sorry, there's only 5 minutes left. Okay. Okay. Okay, let's start this one. Why did you go for 5 minutes? 45 minutes. Video for 40 minutes. It's 45 minutes. All right. Page 8. I would like you to do. Okay, I'll put it on the board now, don't worry. Number 4. So I just want to give you one of these. I'm just trying to figure out which one I should do. 4B. Okay, just write that down, guys. You can put it in your head, but I'll put the question on the board now. We should be getting, I think all our tricks should be getting the books today, so, but I don't know, they have to call anyone all the time. Okay, I'm putting it up. There we go, there's 4B. Just take a picture of that, please. Exercise 1.3, page 8, 4B. Exercise 1.3, page 8, number 4B. It's just one question and it is similar to the question that we just did. They are giving you, listen up please. They're giving you the value of 2 terms and they are asking for the first 3 terms of the arithmetic progression of which the 7th term is 3 and the 12th term is -3. So it's exactly like the example that we just did. Okay, you're just going to practice that. Guys, I want to please urge you to keep up as we are going along. I know it's the first day back, you might not be in the mood to do homework, but please, if you don't practice this today, then we're not going to come back to it again. All right, so please try as far as possible. I know we're sort of busy, but try and keep up, especially in subjects like maths, physics, accounting, those ones where you have to do a specific process. All right, hold on, let me just freeze here. Okay, you can come up. Yes. That's fine.